Section 8.3 coming your way. Still working on some trig. You're going to learn something new today about how to find an angle measure if you know two sides. That's the whole goal today. If you know two sides of a triangle, how do you get the angle measured? So, we'll work our way into that, but again, every time you do trig, help yourself out with this. SOHCAHTOA. Alright, starting with an example right off the bat. Here's our right triangle. And I've got angle 1 and angle 2. Don't know which is what the measures are yet, but I do know all three sides of this triangle. Hypotenuse is 30.6. The short leg is 14.4. And the long leg is 27. Now, my first question, part A. The sine of either angle 1 or angle 2, I don't know which one, I'm just going to call it A because I don't know which one's A yet. You're going to figure, that's what your goal is going to be, figure out which one's angle A, comes out equal to 8/17. Can you tell me, is angle A angle 1 or is it angle 2? Well, you don't know until you check. So let's say, let's do angle 1 first. So, if A was here at angle 1, sine would be opposite over hypotenuse. So the hypotenuse is this, it doesn't move. And then the opposite would be 14.4 over 30.6. Well, it doesn't look like 8/17, but I've got decimals within fractions, so we would have to multiply by 10 on both of these. I'll do it the long way and a short way, so just so you can see. If you times by 10 on top and bottom, because that's hitting it with a 1, that's equal to 1, we would get 144 over 306, and then we would reduce it down and see if it equaled 8/17. But the quicker way to do this, much quicker, we're going to work smarter, not harder here. We're going to get the decimal for 8/17. Just 8 divided by 17, that's the equivalent to this decimal, 0.4705, on and on. If I didn't even have to do all this. I'm going to take 14.4, divide by that 30.6, and look it, I got it right off the bat. So this does equal 0.4705. So in this case, angle A is angle 1. Angle A is angle 1. So I guessed the right one right off the bat. If that one had come out a different value, it would have had to have been angle 2, and we would have checked it by doing opposite over hypotenuse. Okay, now I'm going to change the question. The tangent from one of these two angles, I don't know which one, I'm just going to use a brand new letter, is 1.875. Is angle B angle 1 or angle 2? Well, let's check angle 2 to see if we get that right. So if angle B is at 2, I could start with 1, but I'm going to go with 2. Then the tangent of B, so I'm standing up at 2, tangent is opposite over adjacent. Opposite would be the 27, adjacent would be the 14.4. And now I can see 27 divided by 14.4 is not going to be 1 point something, that would be, yeah, but I'll show you. That top number being, it could be. What am I thinking of? 27 divided by 14.4. Top number's bigger, we're good. 1.875. For some reason I was seeing 17 there. Well, that would still work for me. I don't know what I was thinking, but it is. So angle B would be angle 2 to have that tangent ratio. So got lucky both times. Moving on. How the calculators work. When we were doing the story problems the other day, you learned how to type in a trig function with an angle measure, like say sine of 22 degrees. And if we type that in, 22, we get a ratio of about 0.3746. That's usually the farthest we would carry them out. Well, the calculator has a feature where if you know the sine ratio, it will give you back the angle measure. And it's called the inverse trig function. So, the inverse trig functions give back an angle measure if you feed it a ratio of two sides. That ratio could be a fraction or a decimal. So, where are these inverse trig functions that I speak of? Well, the inverse trig functions are right above, on the graphing calculator and the scientific ones, right above the sine, cosine, and tangent. You'll see sine to the -1, cosine to the -1, and tangent to the -1. Those are inverse trig functions. So, sine raised to the -1, cosine, and tangent. I want to show you on a scientific if it's different. Let's see. On my cell phone, I've got to hit the second. See, there's my sine, cosine, and tangent. But when I press the second, I get the inverse functions. So it's just you figuring out your calculator and where things are at. So hopefully you can do that. So watch what happens now. I already know. So say I had the question, the sine of some angle comes out equal to 0.3746. What angle is that? Well, I know it's 22, but this is how we can get the calculator to give us this. What we do is we say that A is equal to the inverse sine of that decimal, 0.3746. So I type in inverse sine 0.3746. So I'm feeding the inverse function the ratio of the two sides. And again, this was a rounded off 4 places. That's why it's not coming out exactly 22. But we'll always round our angles to the nearest whole degree. So we will get the 22 degrees there. So A is 22 degrees. So we're going to practice finding angle measures. So here we go. Next example. Number 3. Let's go with a couple of parts here. Let's go put a 6 here and a 15 here, and let's say we want to find this angle up here. So our only goal is to find the measure of angle A. Well, we have to do just like when we were trying to solve for a missing side. Figure out which trig function works with these two sides. Well, the hypotenuse is over here. I'm not using that. So these are the two legs. This one is the adjacent leg. This one is the opposite leg. And if you remember, which one works with O and A is TOA. So we're going to set up a tan. The tangent ratio, remember we always put the angle measure here next to the trig function. That's A. Is opposite on top, adjacent on the bottom. Now if I want the calculator to tell me the angle, I have to do the inverse tan of the fraction. Remember, it can be a fraction or a decimal that I feed inverse tan. So inverse tan of 15 over 6. So inverse tan, oops, got all that stuff on there. Inverse tan, oops. Oh, look at what came up, arctan. They didn't even, let me make sure I hit the right button. Inverse tan, yep. It used to be called arctan. Oh, it still is called arctan, but it's not many use that anymore. So inverse tan of 15 divided by 6, we get a 68 degree angle. So angle A is 68 degrees. Try another. Let's go 2.51, 1.06. And let's look for this angle here. So you figure out which trig function first by standing on your reference angle that you're trying to find, identifying these two sides, the 2.51 being across from the 90 is the hypotenuse. This is the adjacent leg. That is CAH, C-A-H. So we're going to set up a cosine to figure this out. So the cosine of A is, I want the adjacent on top and the hypotenuse on the bottom. And now it's just the inverse cosine. You have to remember that's how you get an angle measure back. There's nothing you can do algebraically. It's all calculator work. So the inverse cosine of that fraction, I'm just going to leave it like that. Type it in the calculator. I'll have it. Oops, go this way. Clear all that out. Inverse cosine, 1.06 divided by 2.51, 65 degrees. Okay, one next example. If you are told to solve a triangle or asked to solve a triangle, what that means is you want to find all missing parts. Realizing, oh, that's a 6, because I knew what number was coming to my head. There are 6 parts to a triangle. There's 3 angles and there's 3 sides. So anything that's missing, you have to find when you're told to solve a triangle. So let's start with 1 and see what we get. So we'll go D, E, F. I'm going to give you 14 here and 58 degrees here. So if you look at this, we have the 90, the 14, and the 58 given. That means there's 3 pieces we don't know. Angle D, this side, and this side. Well, angle D is not a hard, we don't have to use trig to get angle D. You know the 3 angles of a triangle add up to 180, or the 2 acute angles add up to 90. You can get angle D without using trig. So the measure of angle D is 90 minus 58, which is 32. Done. Now we've got to find the other 2 sides. I'm just going to throw some letters on there, X and Y. And then we're going to go through the trig stuff like you've been doing. You should be getting pretty good at it by now. Because I know angle D, I can stand here, but I'm going to choose to stand at the given angle just in case I made a mistake there. So if I stand here, that is the opposite. And I think I'll go with the adjacent and hold off on the Y for now. So opposite and adjacent, that's TOA, that's a tan. So the tan of 58 Opposite is the 14 over the adjacent. Cross products, 14 x times tan 58. Divide by the tan of 58. Clear. 14. Divide. I got to go back to the first tan 58. Make sure you're not using the inverse there. X is 8.75. At this point, we could do Pythagoras. Oh, I put a degree there, for goodness sake. That doesn't need a degree. That's a side length. We could do Pythagorean theorem right now and get this hypotenuse, but I'm going to practice the trig. So, practicing trig, I'm going to stand at the 58. Oh, that O was from opposite. I thought that was a degree. Yeah, got it. Hypotenuse. So opposite and hypotenuse, that's so that means sine. So sine of 58 is 14 over the y. Same algebra we just got done doing, 1 times 14, and y times the sine of 58, and then divide. Should finish it up for us. 14 divide sine 58, 16.51. So we have solved the triangle by finding the 3 missing parts. 1, 2, and 3. Let me see, is there anything else we need? I think we're going to be good. Okay, finishing that up.